Hello, sweet people. It is composite functions time. We're watching this video on the evening of the 13th or the afternoon of the 13th, and that will be a Tuesday. So let's have at it. All right, we're going to look at composite functions and one other topic, so I would like to get started here. What I want to talk about is, when I talk about composite functions, is when I have one function inside of another function. So let's say that I have a function that we've been looking at lately, like the arc cosine. And let's say we're looking at the arc cosine of 1/2. That's what I'm going to do, but then I'm going to take the sine of that. So the whole problem looks like that. And this the sine of the arc cosine of 1/2. So you can see one function is inside of another, and that's what composite means. So to do that, we're going to start in the inner chamber, the holiest of holies there, and we're going to find the arc cosine of 1/2. Our training in inverse functions was so good that you recall that this is referring to the angle that has a cosine of 1/2, and you can only look in the first and second quadrants. So here's where we can look for that answer, and that's the only place we're defining arc cosine so that it will be a function. So arc cosine, where do we find a angle that has this as its cosine? When we look at the unit circle, we're looking for a first coordinate that's positive 1/2. So looking over here, I get the over the long, up the short, square root of 3/2 and 1/2. Clear that up a little bit. So that's not the first coordinate. Let's try it up here. Over the short, up the long. There she blows, right there. So there is the arc. We have found the angle that has a cosine of 1/2, and that angle is what this is in radians. So you'll recall, unit circle trained, that is that clear? Is that clear enough? Let me zoom in here. All right, so right here, this angle measurement is pi/3. So the inner chamber now is simply pi/3, and we have to take the sine of pi/3. So going back to the unit circle, here's pi/3. The sine is the second coordinate, and we get square root of 3/2. Let's add a complication. Always complications, just like in life. Sine of the arc cosine of 4/5. Alright, so if I'm looking for that, 4/5 isn't on the unit circle. So I'm going to recognize I can still only look in the first and second quadrants and up in here. But since it's positive 4/5, I'm going to look in the first quadrant. And I'm just going to draw a triangle somewhere there and call the adjacent side 4 and the hypotenuse 5. So now I can use Pythagorean to get this unknown. 4 squared plus side squared equals 5 squared, or s squared equals 25 minus 16, or 9, and the square root of that is 3. So Pythag it, and we come out with a 3. So now we can look at that triangle and quite simply take its sine. Opposite, here's the angle that we found. So the angle that has 4/5 as its cosine has a sine of 3/5. And that is the answer to that composite problem. Alright, let's try, see if you can get this one ahead of me. So it's a race. Cosine of the arc sine of -2/5. So go ahead and work faster than I do. Pull out here. I think you can still see that. I just need more writing space to show up on the screen. So go ahead and draw it. You'll recall arc sine is defined in the first and the fourth quadrants. So we can look up here, and we can look down here, and we are seeing that it's a negative. I'm going to do this one slow. Hopefully you're beating me. So I'm going to draw a triangle down here, and it's opposite over hypotenuse. The opposite, here's the angle, the side opposite is -2. My hypotenuse is 5. Hypotenuse is always positive, no matter what quadrant. It's just thought of as a distance from 0. So 5 is there, and PreCalc to find out what that value is. So it's going to be -2 quantity squared plus that unknown side squared equals 5 squared. So this time we get side squared equals 25 minus 4, which is 21. So we get s equals the square root of 21. Alright, that's life sometimes. So this is the square root of 21 on this side. And I look at this now and find its cosine. Cosine of this angle is adjacent over hypotenuse. So I get the square root of 21 over 5. Did you beat me to it? I hope so. Alright, so let's look at one more of these. Adding a complication. Cosine of the arc sine of x. Now here, I didn't put a number at all, so I have to draw a triangle that has a sine of x. Well, I'm going to need an opposite over hypotenuse, so I'll call that in my mind x over 1. So I know arc sine is going to be in the first or the fourth. Sorry about that. First or the fourth is where I can look for sine, arc sine. So it's positive, so I'll put it up here. Side opposite, side hypotenuse. So this I call x, and this I call 1, and I need to know this value. So I'll call that side squared plus x squared equals 1 squared, solving for s. There's going to be an x in the expression. S squared equals 1 minus x squared, so s is the square root of 1 minus x squared. That cannot be simplified. Alright, so I put that in here. Let me just get rid of this box since I can't write that expression in it. 1 minus x squared. So what is the cosine of this angle? So cosine is adjacent over hypotenuse. So we get square root of 1 minus x squared over 1, but we don't write the 1. Alright, so most simplified is 1 minus x, square root of 1 minus x squared. Alright, we may have gotten to some of those in class today, and if we did, this was double review. Alright, if not, you will meet them tomorrow. Let's look at another situation here where we have a new kind of graph. And I think I'll close this down and do 2 parts so it doesn't take me so long to upload them. So part 2 on the way.